Hey there, friends. I wanted to show you the calculator work for section 4.8 that we're going to be working on. And we're going to be looking at graphing polynomials and looking at their turning points, as well as what we call our max and our mins. You might remember them as the vertex for the parabola, but when I have more than just a quadratic, I'm going to have more than just one turning point. So we call those local maxes and local mins. All right, so if you could please get these two equations typed into your calculator, and you can pause the video here to get those done, and go ahead and pause. And we're going to take a look at the second equation first. So if you see here over the equal sign, it's dark on the equal sign. So that means that it's going to graph both of them. Okay, so if I take a look at my graph, there I have both of the equations. But if I go back to my y equals and I just hit enter, notice how now it's not dark over the x to the fourth. So we're just going to look at the x cubed minus 3x squared plus 5 for right now. Okay, so we're going to go to the graph, and I have the table of values over here as well. And in order to get that, you're going to go to mode, and you're going to scroll down all the way here to full. Yours probably is on full, and you're going to switch over here to where it says graph table. So just use your arrow keys and hit enter, and then go back to your graph. Okay, so and if it's not situated the way mine is, you can just use your arrow keys to move up and down on there. So what we're going to do is this. I want you to notice some values here. So if we take a look at our graph, you probably notice that at x equals 0, I have a high point, all right? And that's what we call a local max, all right? So right here at x equals 0, right around there. And here I can tell that it's at -1, it's 1, then it goes up to 5, and then it goes back down to 3. So somewhere around here, there's going to be a local max. So the function is increasing, 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 increasing until it gets to this point, and it looks like it's 0. And then it's going to start decreasing. And it looks like it decreases until it gets to about 2, and then it starts increasing again, okay? So you can look at your table of values and notice that here at 2, I go down to 1, and then it starts increasing, and then it keeps increasing. Okay, this is a cubic function, so that makes sense. Now, we already know how to find the x-intercepts. So let's just review that really quick. We're going to go to second calc, and we do the 0. So we hit enter, and it asks for left bound, so we're going to use our arrow key to hit enter, and then our arrow key again. And those two arrows, remember, have to be pointing towards one another. And if you want to guess, you can move your arrow key back, and you hit enter. And there is your x value right there at -1.1. Okay, so but now today's lesson, I want to find the local mins and the local maxes. Okay, and notice also how this is part of the location principle. Notice here, my value is if I go down a little bit. If when I'm tracing this function, so I'm going to trace it for now, notice how my values are negative over here. They're negative, and then it turns to positive, okay? So in between these two x values, I know I must have an x-intercept because, and that's the location principle, one of your core concepts. When my functional value switches from negative to positive, in between those two values, there has to be an intercept. Okay, so in between those two values, there's got to be an x-intercept. Okay, so now let's figure out how to find the local max. So we're going to go to second calc again, and we're going to find a maximum. So we're going to hit 4, and the left bound, you can just put it there. And then we know it's got to be to the other side of this guy, and then we hit enter. And there we go, our maximum. Now, here's something interesting. Notice this value here, this -7.648. Well, that's e to the -7. So what that means is it's -7.6 times 10 to the -7th power. And if you remember from your time with scientific notation, if you raise something to a negative power, that's going to be a really, really small number. So this is the calculator's way. Sometimes when you have a number like that, it actually means 0. And if you see here in your table, it does say that x equals 0 and y equals 5. So that's your local maximum. So why don't you take a minute to see if you can figure out how to do your local minimum now that we've just gone through the local max. All right, and I'll go over that right now. So I want a second calc. I want to do the minimum. So that's going to be number 3. I hit enter and I go over here and I go do my left bound, and then I'm going to do my right bound, and I'm going to hit enter. And there it goes. It gives me my y value. Now, notice here, again, there's rounding error. When y equals 1, it says that x equals 1.999999983. But if we were to take a look at our table of values, I'm going to quit out of here for a second. So remember, that's, and this value here, it really looks like it's pretty close to 2. So if I go back to graph here, remember, take a look at this x value, 2, 1. So I know that my minimum really is 2. That happens sometimes with rounding error. So you really need to be very careful when you're using your calculator that you're smarter than your calculator. So when it gives you a value like that, make sure that it's not just rounding error. Okay? So there's your local maximum here at 0.5, your local min at 2.1. That local max also is your y-intercept because it's the constant value. Okay, and if you were talking about the end behavior, you would say that as x approaches negative infinity, f of x approaches negative infinity, and as x approaches infinity, f of x also approaches infinity. Okay, and we're also going to now I want you to take a try at this equation, x to the 4th. See if you can find the local mins and the local maxes, and pause the video and go ahead and do that. Okay, so I'm going to hide this graph and take a look at that graph. So here you have 2 local mins, right? So you need to make sure that you calculate both of those. So second calc min, and we'll do this one over here first. Enter. I don't know if these values are going to be quite as pretty, and they're not. So your value is here at 0.917 and y equals negative 5.084. And your intercept here, your x-intercept happens to, y-intercept happens to be 0, 0 because there is no constant. You could do the second local min. This one has 2 local mins. And if we want to calculate the max, we're going to go to 4, the local max, and scroll over here, and then over here, and there's our local max right there at negative 0.8 and then 3.2 approximately. Okay? All right. Again, end behavior as x approaches negative infinity, f of x is approaching infinity, and as x approaches infinity, f of x is approaching infinity as well. This is an x to the 4th, it's a quartic, so I know that my end behaviors are going to be the same. All right, hope that helped.